I can't speak exactly for ANSYS, but I'll give you my thoughts on the trends I see that I think that it's going in this direction. So a lot of these new satellite companies and ideas are revolving around the idea of many satellites up there. So you've seen some of the additions to the DME tools over the last few years have been making that easier to design for in the software. So I think that they're going to be continuing to add features for these giant constellations of thousands of satellites, offering us all kinds of different services from space. And I think that is going to go hand in hand with more automation. And you see them already, the ANSYS already starting to implement some more automation and probably based on AI tools, right? Like that's what everybody needs to do. And it's just exploding, like Jim was saying, to a level of, it's very healthy. There's tons of people doing it and they're making tons of awesome stuff. And so I think the tools will evolve so that small groups can solve these big problems with many things up in space and many payloads and also lunar, right? Like there's almost 100 lunar missions planned in the next decade. Right? There's so many things going on in space, and you've seen Ansys add specific capabilities since then, catering to the lunar crowd. So I'm sure that's going to happen with Mars as well, and that's all those things are pretty exciting to me. That the moon stuff, and then the number of satellites that are going to be up there, giving us these things like global internet. Right? That's going to be fantastic, and there's going to be choices for global internet, and it's going to be great. It's going to be very connected time, so to speak.
Yeah, I see it sort of from the other side too, right? I really enjoy building out a workflow, right? Building out a tool set and helping designers, engineers connect tools together. We've been scripting and doing that sort of a manual way for quite some time. So I'm enjoying seeing this progression of the tools being very connected to each other, less mistakes by humans. You mentioned sort of AI, right? But the reality is we're trying to use software algorithms to fill the gaps where we don't have the data. Humans are really bad at making up data, right? We're really bad at plugging that gap. Statistical math, pretty good at it, right? So the other thing that's kind of happening too, right, is it's not just the physics, right? We're not just seeing this flow down from, say, mission level to physics, like structures, fluids, thermal, high frequency, RF. We're also seeing it connected to, for those that care, right, risk, revision management, right? Sort of this layer of process control that becomes more and more critical as you have a more and more complex system, right? So, data management systems, release tracking. I mean, these things are going to get very complex very quickly. They are complex. Let me say that they are complex, but as the small and medium sized enterprises start to build out new value and new solutions, those solutions start off as maybe a single point solution and they turn into a system of systems, to use your term, Josh, very quickly. So
Mhm.
we're seeing it really embed into the sort of the model based systems engineering sort of mantra. So for me, that's exciting because I like seeing new tools kind of talk to each other and automate. Just makes it easier for the designer.